everybody, this is Mrs. Ellsworth. This is the Chapter 12 notes, and this is all about forces and also about motion, because quite often when you apply any kind of force, if it's enough, you'll have some motion going on. Okay, so what is a force? And that's what we're really thinking about. And there's all kinds of definitions about it, but it's any time that you are changing an object's shape by pushing or making something move, any time that you're causing any type of motion like that to make something accelerate or to change the shape of an object by applying a force to it, that is what we call a force. But I have and most physics teachers would believe that just a push or a pull is basically what a force is about. So in your notes, the main thing to remember is that I will always write down the definition for a force as a push or a pull. How do we measure force? So force is not like mass, where you just place it on a balance. It's not like something that you measure with a meter stick. We use a spring scale for it. And so we'll pull it along at a constant rate, and then we can measure on here. We can measure how much force it has. So what kind of units do we use on one of these spring scales? The unit is called a Newton. Okay, and Newton is a very, very small unit, so it doesn't take very many newtons of force to get a small object moving. Okay, well, what happens to make forces motivate or move an object? Well, we combine these forces. And when we combine these forces, here you'd have something in the negative direction, and you add it to the positive direction values. And so whatever newtons that they're pulling on this side has to be equal as this side, because this looks like that this is a balanced force. They are both not moving, so it is a balanced force. Balanced force means that there is no acceleration going on. If it was unbalanced force, like all of you guys against your teacher here, that'd be very unbalanced. You guys would be pushing me, like pulling me away like crazy, and so it'd be unbalanced. So like my small force compared to your large force here, we would go and combine those negative and positive values to find out what your total net force is. So net force is really the total force of all of the different forces that were measured. Okay, here's another example. If these two forces, we like to show forces with arrows. Okay, these arrows are both about the same size, but they're in opposite directions. So if you go and add this positive value to this negative value, or vice versa, I guess this would be negative and this would be positive, then you would find that you'd have a net force of 0. So there wouldn't be any acceleration. Okay, here's an example of a young lady who is trying. So this young lady, she will apply this force on this side, probably will just designate that as a negative force, and then positive force on this one, because she's going to try and mold this clay so it is the same on both sides. Otherwise her clay pot that she's trying to make here will get all offside, and because she'll accelerate to one side or the other. If you've ever thrown a pot, you know it's very hard to center this and to get it going that way. It takes a lot of force, but even force on both sides until you can get it right in the center. Okay, here's an example of two kitty cats, a balanced force. Of course, that makes sense. That's almost too childish for us, but it's a good drawing. Okay. And where's my other picture at here? Okay, I just think that this is a really good way, and it's also a good way to talk about what we're going to be going into next. But when you think about it, she's got friction in her wheels that are going against her. Friction opposes the motion that you're applying to this. So she's got to push to overcome that friction to be able to go forward. So she needs a larger applied force moving here, okay, moving her forward, and she has to overcome the friction of the bike. She has to, if it's got a serious wind going straight at her, she's also got air resistance to deal with. Now, the faster she goes, the more air resistance and friction forces increase, but she's just got to keep overcoming them by applying more force. So this is a great way of showing some forces that are naturally occurring called frictional forces, and we're going to talk about the 4 different kinds here in just a second here. Oh, I should also add that she needs to have an unbalanced force to make herself go forward. Greater applied force than friction force. Okay, so here are the 4 types of friction. These are opposing forces, okay, and static friction is the first one, and static is just getting something to move. We've got a lot of contact here on the floor, so it's going to take a greater force to get this thing rolling and get it moving. I shouldn't say rolling, to get it pushed forward to get it moving. If you would go and take like a desk or your pop can or anything and take your finger and just go push it to the side. It takes a lot more force just to get it started than it is to keep it going. Static friction is one of the larger forces, frictional forces that there are. It also means that static means that it is stationary. They've got the same root word, and so something is not moving. You go and it takes a little bit more energy to get it going. Okay. Sliding friction. Once we get it going, this right here is also called kinetic friction if you want any other forces to look it up. But once it's moving, it's sliding across the floor like this, it takes less force to keep it going, but it's still an opposing force. Otherwise, it'd be easy to push that, and he wouldn't even have to push on it anymore to keep it going. Okay, rolling friction. Now we can add some wheels to this, put it on top of a dolly, and it'll be even easier to roll it. So there's less friction in rolling objects. My dad used to build homes, and he used to go and roll the whole upper level house onto the basement, and they would set steel bars going across it, and that would actually be their rolling friction so that they could get all those so that when they slid the house on top of the foundation, it didn't go and break the foundation, so that they would put those long iron rolling bars across the top for some rolling friction. It reduces the sliding friction. Okay, and fluid friction. Fluid friction could occur inside of liquid. Think about your boat going through the water, how it makes that certain pattern after the boat, because the boat is now sliced through the water, and it creates so much friction that actually there's a space where your boat used to be, and before the water goes back together. And so fluid friction can occur in liquid. Okay, it can also occur in air. So fluid friction is still also like falling through the air, free falling through the air until you pull your parachute, and then there's a lot more air resistance there. The fluid friction of your car versus a truck, or even a big huge truck going through the air, creates even more air resistance, and that's because that fluid friction is an opposing force against whatever is going through the air or the liquid. Here's some more examples. Okay, there's some sliding friction. We've got a runner sled there with very less sliding friction because there's only just 2 thin runners. So it should be able to go pretty quick on packed snow. Okay, roller blades. Those have got ball bearings inside of it, so you've got rolling action within the wheels themselves, so that reduces your friction even more. Another way to reduce your friction is to create more liquid between your surfaces, and like applying a lubricant between things. That also helps too. And of course, that's just talking still more about more fluid friction, like this example of a swimmer plowing through the water, and the fluid friction that opposes him that he has to overcome, but he's still able to, because fluid friction has reduced friction compared to like sliding. Try and imagine swimming on a carpet is quite difficult. There's too much friction. Okay, so we've got these contact forces we were just talking about, balanced and unbalanced forces, and we got those opposing forces called frictional forces. And so in the next video you can look up and we'll talk about the non-contact sports.